All right, we're going to be finishing up our notes on 6A. So I did end up skipping example 2 because I want to go over example 3 and example 4. So we are on the very last page. The back of it is nothing. So the last two examples in our packet. So example 3 says, show that both sides of the equation, I'm not going to read it to you, it's right there, simplify to secant times cosecant. So this is my goal. So this is what I want to get to for both sides. And if I'm trying to show that both sides simplify to this, I'm going to do my two sides separately. So I'm going to start with my left side, and the left side is everything to the left of my equal sign. And I'm going to do that work over here. So for my left, I'm going to write what I have. So I have cosecant over cosine. And I want to start simplifying. Trying to get here. So I do have cosine in my denominator. Right now, I'm going to leave that there, but I know that I can rewrite cosecant. So in the next row, I'm going to rewrite cosecant, which is 1 over sine, and then I still have cosine in my denominator. I don't want to have fractions inside of fractions, so right now this cosine is technically over 1. So if I wanted to get it out of my denominator, I could multiply by the reciprocal. So I'm going to take this and I'm going to flip it and multiply it next to my 1 over sine. So in the next row, I still have my 1 over sine of x, and then we're going to see if this color shows up. I do have to flip it, so I have, that's a little late, I'm so sorry, let me grab a different pen. I have 1 in my numerator now, and then I have cosine in my denominator. That didn't work that much better. But. So now that I have this, I look back at my goal, and I know that I need secant and I need cosecant. Well, what I have right here, I know that 1 over sine is cosecant. So I can change this back to cosecant. And then 1 over cosine is secant. So I have cosecant times secant. And they're being multiplied. So even though these are in a different order, because it's multiplication, order does not matter. We know 2 times 3 is the exact same thing as 3 times 2. So getting cosecant times secant does in fact match what we were trying to get to. And so we just showed that the left side does in fact simplify to give me secant times cosecant. So now we're going to do the same thing to the right side of our equation. So we're looking at everything to the right of our equal sign. And I'm going to do that on the right side of my notes. I'm just going to write down what we have. We have cotangent plus tangent. So right now, I don't really notice anything, so I'm going to try to write them in terms of sine and cosine. So for cotangent, I know that is cosine over sine. And I'm adding on to that tangent, which I'm going to rewrite in terms of sine and cosine as well, which is sine over cosine. So because our two fractions are being added, we actually cannot cancel out our sines or cosines. If they were being multiplied, they would cancel each other out, but unfortunately not here. Also, if they cancel each other out, we're not meeting our goal because we're still trying to get to the secant times cosecant. So when we're adding fractions, the only way we can actually add them is if they have common denominators. Right now, I don't have common denominators, so I want to create common denominators. So I'm going to start with the fraction on the left. I just rewrote it. Oops, sorry about that. And I'm going to multiply this one by cosine of x over cosine of x. That will give me a denominator of cosine times sine. And then for my second fraction, I can multiply this one by sine of x over sine of x. And I will have the same denominator, cosine times sine, same thing that was here, cosine times sine. So when I simplify this, I'm going to multiply straight across, so cosine times cosine would give me cosine squared. And then my denominator is cosine of x times sine of x. On the second fraction, I have sine times sine, which would give me sine squared. And then cosine times sine, I just kind of squish them together. Now that I have common denominators, I can make it into one fraction. And then looking ahead, I would have cosine squared plus sine squared in my numerator. Well, cosine squared plus sine squared is actually one of our Pythagorean identities. Cosine squared plus sine squared is 1. So I'm going to kind of skip a step here because I'm running out of room. Towards the bottom. I have 1 in my numerator, and then my denominator is cosine times sine. I want to go back to this a little bit. On your reference sheet for your Pythagorean identities, it does say sine squared plus cosine squared, but we know with addition, order is commutative, so we can flip those around and it would still give us that 1. So now that I have 1 over cosine times sine, hopefully it looks familiar to kind of what we had here. I'm going to go, well, I'll go right underneath it. What I could do is I could rewrite this to make it kind of look like this and break up my fractions. So I could do 1 over cosine times 1 over sine, because if I multiply those, I would get right back to where I was. And now that I have 1 over cosine and 1 over sine, I can see that 1 over cosine would turn into my secant of x, and 1 over sine would turn into cosecant of x. So I'm just going to rewrite that, and we reached our goal. And so that one worked out as well. There's one more example we're going to look at. So the very last one, example 4 says that we want to show both sides simplify to tangent plus 1. So I am going to start off the same way. I want to only focus on one side at a time. It doesn't matter which side you focus on first. I usually pick the one that I think is the easiest, but now it's kind of, it might be hard to tell which one is easier than the other. So I'm going to actually start with the left one. So for the left, I'm just going to rewrite what I have. And I have 1 plus cotangent over cotangent. And then it's my equal sign. So I only want to focus on this part. Since I have the addition in the numerator, I can split up my fraction into 1 over cotangent plus cotangent over cotangent. We can do that. So now when I look at this, I know that, well, cotangent over cotangent would cancel out, and this part here would turn to 1. So I'm going to do that right now. And then if I know that I have to get it to tangent plus 1, well, I have my plus 1. So I want to think about how can I rewrite cotangent in terms of tangent. So I have 1 over, and then cotangent is actually 1 over tangent. Well, if I have a fraction in my denominator, I know that I can multiply by the reciprocal. So I'm going to take that and I'm going to flip it and multiply it. So this one was from the numerator. And then I am multiplying this by tangent of x over 1. And I still have my plus 1. Well, tangent over 1 is just tangent, and then tangent times 1 is still just tangent, and so we get tangent plus 1. I also realized I was using theta, and then I switched to x's, and I switched back to theta. I'm sorry. It doesn't matter what your variable is. So we proved that it does in fact get to tangent plus 1. So now we're going to look at the right side, and we have this whole thing. Now, I don't want you to be intimidated because it does look intimidating. So I have tangent of theta plus cosecant squared minus cotangent squared. So I do have 3 terms, and since I already have a tangent here, and I know that's part of what I want to get to, I really just want to focus on these cosecant squared minus cotangent squared. Well, since they're both being squared, I'm actually going to double check my reference sheet. Well, cosecant squared minus cotangent squared is on your reference sheet, and this whole thing turns to 1. So if I rewrite this, we didn't do anything with our tangent, so we can bring that down. And then this part that I underlined in green turns to 1, and it was a positive 1. And so we got our tangent plus 1 in only like 1 step. And we verified it.